So if you're a developer today, you've definitely heard of NoSQL. It's everywhere. But it's so much more than just a buzzword, right? It's really a fundamental shift in how we think about data, moving from just protecting data integrity to designing for insane application performance and scale. So let's pull back the curtain and demystify what NoSQL is all about, and maybe figure out if it's the right move for your next big project.
Okay, let's just get right to it. The big question that's probably on your mind, with all this hype around NoSQL, is it finally time to just ditch SQL altogether? Well, the short answer, nope, not at all. The real answer is that it's about knowing you've got a whole toolbox, and you need to pick the right tool for the right job. And to do that, you've got to be able to speak both languages.
Think of this slide as your personal Rosetta Stone for databases. It's how you translate your brain from the SQL world to the NoSQL world, specifically a document database like MongoDB. You can see how the concepts map over pretty cleanly. What you used to call a table is now a collection. A row is now a document. And check this out. Even something complex like a join has an equivalent. We can use something called .lookup. Or, as we're about to see, we can just embed the data right where we need it. Keep this little translation guide in your head as we keep going.
All right, first things first, let's get one thing straight. NoSQL isn't one single thing. It's more like an umbrella term, a whole family of databases that decided to break free from the super rigid structure of SQL. Each one is built to solve a different kind of problem, so let's take a quick look at the 4 main flavors you're going to run into out there.
Here are the 4 heavy hitters. You've got key-value stores like Redis, which are just ridiculously fast for simple stuff. Then there are column-oriented databases like Cassandra. These things are built for absolutely massive web-scale data. Graph databases like Neo4j, perfect for when you're dealing with crazy interconnected data, like a social network. And finally, document databases like MongoDB, which is what we're really going to zero in on today, because they're super flexible and honestly just a natural fit for most modern web apps. Okay, enough theory. You've picked your database. Now what? How do you actually get your application code to talk to it? Let's walk through the essential checklist for making that first, all-important connection. Making this first connection has to be secure and efficient. It's totally non-negotiable. First up, you're going to use a driver or an SDK that's specific to your programming language. You'll give it a connection string, which is basically the database's address and your login info. Always enable TLS/SSL to encrypt everything. And here's a pro tip. Please listen, never, ever hard-code your database passwords in your source code. Use environment variables. Finally, you'll want to set up connection pooling to manage connections efficiently and configure timeouts so your app doesn't just hang forever if the database doesn't respond.
So we're connected. Now for the fun part, actually doing stuff with our data. We're going to look at the core operations, and you'll see they feel really familiar, especially if you're coming from an SQL background.
You've probably heard this acronym a million times, but it is the foundation of pretty much any database interaction. CRUD. It stands for create, read, update, and delete. These are the 4 basic things you need to do to manage your data. Doesn't matter if you're in the SQL world or the NoSQL world. Listen, performance doesn't just happen by magic. You have to design for it. To keep your application feeling fast and snappy, you got to remember these key things. First, be specific. Use filters in your queries and only ask for the fields you actually need. It cuts down on network traffic. If you've got huge lists of results, always use pagination. But the most important one, create indices for the fields you search by a lot. Seriously, an index works exactly like the index in a textbook. Instead of flipping through every single page, the database can just jump right to the data it needs. It makes your queries orders of magnitude faster. It's a game changer. Okay, this next part is where the rubber really meets the road. We're going to walk through the most common scenario there is, moving an app from a classic SQL database over to a NoSQL model. This example is going to show you exactly what that fundamental shift in thinking really looks like. All right, so here's our before picture. In the good old relational world, we've got a nice, clean students table. It has an ID, a name, a course. Everything's neat and tidy, very structured. But, you know, a student is more than just a name and a course. They also have projects. In SQL, that means, you guessed it, a second table. A projects table linked back to the student with a foreign key. Now this works, but to get a student and all their projects, we have to do a join. And at scale, when you have millions of rows, those joins can get super expensive, forcing the database to work really hard, reading from all over the disk just to piece one little bit of information together. And this
This is the aha moment. This is the whole point. In our new NoSQL design, we just get rid of that second table. We simply embed the projects as a list, an array, right inside the student document itself. All the information about one student lives in one place. It's a total redesign, and it makes grabbing all the data for a single student incredibly fast and efficient.
So how do you actually do this? Well, it's a pretty clear 6-step process. The first 2 steps are all about planning. You look at your old SQL schema, and then you design your new awesome embedded document model. Steps 3, 4, and 5, that's the mechanical part. You export your data, probably to CSV files, import it into your new collections, and then you double-check to make sure everything made it over. Finally, step 6 is for cleanup, recreating any last relationships that you couldn't handle just by embedding.
Okay, so we've covered the how, but none of that really matters without the why. Why has this NoSQL model gotten so incredibly popular, especially with modern web developers? Let's connect the dots here. You know, the answer is actually pretty simple. It's all about synergy. Think about it. Modern web apps live and breathe JSON. Your front-end framework sends JSON to your API processes JSON. So why would you want to have this awkward translation layer at the database level? Document databases store data in a format that's basically JSON. That means the data just flows seamlessly all the way from the database to the user's browser. It's perfect for rapid, agile development.
And the best part? The entire ecosystem is built around this idea. For pretty much every major language and framework, there is a mature, battle-tested tool to help you out. If you're using Node.js, you've got Mongoose. For Python, there's PyMongo. For Java, Spring Data MongoDB. A lot of these tools are what we call ODMs, Object Document Mappers. And they basically let you treat your database documents like they're just native objects in your code, which makes development feel incredibly intuitive and natural.
Look, if you remember just one single thing from this entire explainer, I want it to be this quote right here. Migrating to NoSQL is not a one-click export. It's a data model redesign. The real true power of NoSQL doesn't come from the technology itself. It comes from you rethinking your data structure to perfectly match what your application actually needs to do. And that brings us full circle, right back to you and your projects. I want you to think about the applications you're building right now. Think about your data models, those complex joins, maybe some of those performance headaches. And now, ask yourself the question on the screen. Is your data ready for a redesign? Thanks so much for joining me.